Hi guys, this is a Calc video, video 5-9, to be watched the weekend of Friday the 13th. And the corresponding homework is one problem on page 17, number 39. I haven't done notes for this yet, so I'm going to try to do it just right out of the gate. So we're going to find f of x knowing its derivative. So find f of x if f prime of x equals that. Now, guys, usually when you're finding it, so we're finding the antiderivative of that. So f of x is the antiderivative of its derivative. And normally, like if they just wanted you to find f of x, you'd have a plus c at the end. Because when you're finding an antiderivative, usually you're not just finding one function. You're finding a whole family of functions, all of whose derivatives are the same. But if they give you a condition about the function that you're finding, then you could actually figure out what that c is, and you could find the exact function. Okay, so the derivative together with a condition will lead us to an exact function, not a family of functions. But first we got to find the family, and then we'll find the exact function. Okay, so I'm going to use the power rule backwards. So we've got f of x is going to be equal, bring down the 9, and then antiderivative of x squared is x to the third over 3 minus, so that's the constant multiple rule when I'm just bringing down the constant multiples. So that's an exponent of 1, so we'll get x squared over 2 and then plus c. So f of x equals 3x to the third minus 7x squared plus c. And then they're telling me that f of 1 equals 2. All right, so I'll go up here and I'll use that condition. F of 1 equals 2. So right below this side of the equation, I'll plug 1 into the antiderivative that I just found. And so we'll get 3 minus 7 plus c, and then I'm just bringing down that 2. And then this is negative 4 plus c equals 2. So c equals 6. So f of x equals 3x to the third minus 7x plus 6. I think these are fun. They're very straightforward. Okay? So first, so this f of x represented the family of all possible functions that have this derivative. Okay, so this here is the antiderivative family. But there's only one member of this family for which this is the case. All right, so we found that it was this member. Okay, so now, example number 2, we're going to do the same thing, but we're given the second derivative, so we're going to have to go backwards twice. So find f of x if f double prime of x equals 150x to the fourth plus 24x squared minus 14. And they're going to give us two conditions. So this condition, knowing that f prime of negative 1 is negative 24, will allow us to find the c on f prime, and then f of 0 equals 1 will allow us to find the c on our final answer, f. Okay, so going backwards. So the first antiderivative I take is going to just give me f prime of x. Alrighty, so bring down the 150 and go ahead of me, guys, or speed this up. X to the fifth over 5 plus bringing down the 24, x to the third over 3 minus 14x. Guys, the antiderivative of a constant is just the constant times x. And if that's not clear to you, then you can go x to the 0 and then use the power rule. But this is much faster. The antiderivative of a constant is just the constant times x or whatever variable you're taking the antiderivative with respect to. And then don't forget that plus c. Alrighty. So let me simplify this. 150 divided by 5 is 30, right? That's, okay, yeah. I'm just being cautious. Minus 14x plus c. Okay, so this is the family. This is the antiderivative family. And we know that f of negative 1 equals negative 24. So on the left side here, I'm going to plug in -1 into the antiderivative that I found. And I get -30 minus 8 plus 14 plus c equals -24. And then what is this? -30 minus 8. So -38 plus 14 is now -24. Okay. So c minus 24 equals -24. So c equals 0. Okay. So f prime of x equals 30x to the 5th plus 8x to the 3rd minus 14x. All right, now going backwards again. So f of x equals, I bring down the 30, and some of you might do antiderivatives faster than I do, but that's fine. I'm going to go slow in case it helps someone. X to the 6th over 6 plus 8x to the 4th over 4. 14 x to the 2nd over 2 plus c. So f of x equals 5x to the 6th plus 2x to the 4th minus 7x squared plus c. Alrighty, and then over here I'll use the fact that f of 0 equals 1. On the left side of this equation, I'll plug 0 into the antiderivative that I found, and I end up with c, just plain old c, equals 1. So the final answer is that we've got 5x to the 6th plus 2x to the 4th minus 7x squared plus 1. So this is the single member of the antiderivative family that satisfies these two conditions here. Okay. Now, as a last thing, we're just going to practice estimating a definite integral using a graph. So use the graph to estimate the integral from 1 to 7 of f of x. Now, what does an integral mean? A definite integral mean? It means the exact area under a curve. And you can't find the exact area if it's a curve like this. Like if it was made up of like triangles and rectangles and trapezoids and circles and things we had area formulas for, then we could find the exact value of the definite integral. If we had the function itself, we could plug it into our calculator, or in the future we'll have methods by hand whereby we could find it. But here all we can do is count the boxes to estimate. So from 1 to 7. All right, so there's 1, 2, 3, 4, 5, 6, 7. All right, so I have to, okay, so I'm going to have some positive area over here and some negative area. So I'm going to count the boxes. I feel like this is 1, a full 1, 2, 3. This is not a full box, but if I combine it with that one up there, I'll have close to 4. This is enough to call it 5. And then I'll call this I'll call these together, giving us like 6.2. All right, so let's say that area right there, I'll say is, I'll say 6.2. And then I have, the function goes below the graph here, so I'm going to have some negative area there. So I'll say 1, 2, I'll call that a full 1, so 3. And then these two together are making more than a full 1. Okay, so I had 1, 2, 3. I'll call it, I don't know, 4.5. A lot of you are probably better at this than me. I'll call that 4.5. All right. So when I compute this integral, I'm going to do the integral from 1 to, what is this? 1, 2, 3, 4. That was 4 right there. the integral from, I'm going to use additivity. The integral from 1 to 4 of f of x plus the integral from 4 to 7. Alrighty, this integral is about 6.2 plus this integral is about 4.5, but that's a negative area. Alrighty, so I get 6.2 minus 4.5 is 1.7. Okay, so about 1.7. Alrighty, so there is that. And your homework again is page 17, number 39. It's a second derivative one, so very similar to example number 2. And we will have a quiz tomorrow that is similar to it. All right, guys, have a great day. Bye-bye.